None of that is something then. If I not that, then something else. Yeah. All right. Shanta, are you there?
Yes, sir.
Okay, good. Sound like you were there before. Marlon.
Yes, sir.
Oh yeah, very sound strong one. Sound like yeah. Giovanni.
Yes, sir.
Okay. Sounds so shy. Hmm. All right, Dijani,
Yes, sir.
you're there. So tell me. All right. Well, you're gonna tell me afterwards why I'm not hearing from you in terms of the love. So I won't ask it right now. Um, Khadija, are you there?
Yes, sir.
Okay, good. Yeah, I hardly hear your voice. Good to hear it tonight. Um, of course, Dwayne is there, and Janari is there. Amari, I think I heard you earlier. Kayla also was there. Benito, you there?
Yes, sir.
Okay, and Daniel. Okay, so maybe a little difficulty there with the microphone. All right, Michaela.
Yes, sir.
Okay, good. All right. All right. So let's get on with this, guys. We want to get this lab out of the way and race it. Although, as we said, the instructions in there. Let me get this SOS out to persons who would need to be here. All right. So, all right. So that's it. All right. Hold on a sec. So person. All right. So sending that SOS there. All right. So now, yeah, let's begin this. So as you can see, notice at the start of the lab, I try to put which part of the syllabus you'll find. It's 3.2, so this is electricity. That's section, I think it was section D. Section D. I should have put that here as well, I think, in section D. I also confirm that though. All right. So this now, guys, is usually the first thing that is starting in electricity. And you'll get to understand the what electricity is by this. This was how electricity was, you could say, discovered. You could mischief happening with the American statesman Ben Franklin. Anybody hear about Ben Franklin?
No, sir.
Nobody know Ben Franklin? Nobody in this class knows about Ben Franklin?
Sir, I heard the name, but I don't remember who he is.
I don't remember who he is. Okay. Interesting. Well, what can I say about Ben? If you have ever held $100 bill from the US, that's the guy that's on it.
Yeah, in the money.
Yeah.
I am the funny money, sir. No.
Okay, that's it. I don't know why you guys exposed to. I know you guys have it in mind to be rich. And then one of the signs of riches is to hold a lot of these US dollars, especially the largest denomination of US dollar, which is the $100 bill. And on that $100 bill, there is Ben Franklin, who discovered electricity. Oh God. Yeah, that's reality, guys. Right? This is the world we're living in. Right? This is the world we're living in. So this now is $100 bill information for you guys. All right. I know you guys would like to have your hands or own $100 bill with Ben Franklin on it and not Donald Sangster. Because Donald Sangster, $100 them no value nothing, right? But certainly Ben Franklin, that guy is responsible for what we're doing tonight. All right. No. So, all right. Have you ever heard the term static electricity?
Yes, sir.
Yes, sir.
Yes, sir. I see people do it like from pen to paper, like something like that or something.
Pen to paper.
And I think it was something to do with skin, sir, like some skin. I don't remember how I think I did see it before, sir.
Hmm.
Either something to do with the skin and a paper, but I know it had something to do with a paper or something.
All right. Well, all right. Let's take a look at the roots of that information there. So that $100 information that we need to know is this. No, I'm gonna show you something. This is actually a painting. It's an 18th century painting. Now I'm gonna show you here. And those of you who into art, this is depicting what Ben Franklin did in the 1700s. All right. Now, all right, as you can see here, you see what does this look like here? This black object that him went on
Key,
to here.
sir.
Look
Yeah,
like a
man,
key.
like some light,
Mm,
like he might use it as a light switch or something. Don't know.
using it as light. All
I'm
right,
a
that's
key, like my pull the key, sir. Like you tie something to the key to sir and my pull.
yeah, that's the idea that he yeah, he was an adventurous person. All right, let's look at this picture. You see, I'm dressed up like first time American pilgrim, but this is something here. All right, I'll show you another version of this because this is where the knowledge came from. Another rendition here, Ben Franklin, and then people, and this is how he found this way on the $100 bill. I mean, he did something great for America, especially at a time when, well, they would have just gotten independence. So yeah, so he was around at the independence time there. But aside from this guy, all right, this picture is showing you the same key. What's happening in the environment? What is seen happening around?
Sure, man.
Sir, like he might use the lightning for strike it, I
He
don't
is
know,
using
sir.
the lightning.
A
Okay.
kite.
Like if I
Sure, when kite and rain a fall.
All right, hold on. Very good, Kanye. Thanks for very good to join us this evening, you know. So yeah, Kanye, this definitely and Janari is trying to explain a similar thing. But yeah, there's definitely rain, there's a kite involved, and
the key, sir. Like much I pop the key.
the power up the all right, I tell you what. You know what this guy did? This guy actually carried out a plan and design lab in the 18th century, right? He had no physics teacher, by the way. He was just a sensible man. In fact, a sensible politician. Right now, if if we had politicians that use their brains like how he was using his brain, then Jamaica would be a much better place. But this guy had a nudge, he had an idea in his head saying, you know, what if because everybody knew about lightning, and in those days they thought lightning was God's power to you know to as wrath, you know, to discipline people, and when him angry and so him send lightning, you know. So he was living with people who had that mindset at that time, so they saw lightning as an expression of powers from gods, and even in before those days you had this guy named Thor. Everybody ever hear about Thor?
Yes, sir. Everybody knows
Yeah.
Thor, sir.
Think so. Man with the hammer, the jaw lightning.
Sure,
Current,
Thor,
everything.
sure. Thor,
Yeah,
sir,
yes.
Thor.
Thor, yes, Thor.
Oh,
Yeah. All right. So, well, all right. So they had all kinds of explanations for lightning. Them used to say it was Thor, which is the Nordic god of thunder. You know, that's his expression of power. You know, to
Sir,
the other gods.
you have wanted a god to sir, like them barbaric people. They call it not barbaric.
Right.
And some people from Sweden, sir. Like them people usually have some
It's the
gods,
same
sir.
people I'm talking about, General. They are called
Them,
Vikings.
sir.
And they're not barbaric actually. They are lovely people. But yeah, they are Vikings. And they believed in Thor, and they believed that lightning was his power. But Ben Franklin was call him American. He would have been a British descendant, but he was in the Americas at the time. And he had a nudge. People were moving away from superstitious things into being scientific people. And he was saying, well, this thing could have power that we could use. What if we could harness this power? So again, yeah, that idea we're saying, all right, he realized that anything that's metallic, the lightning would strike near it or so. So he said, well, all right, but if I can get close to the lightning, in those days there weren't any airplanes, anything to take them off the ground except air balloons, and that was in Europe. So so he had a nudge. He said, okay, if I could fire a kite, and I'll put the key on it because the key is made out of metal, and then let's see what happens. And he did that, and he realized that, all right, lightning tends to strike the tallest object around. And there you go. It did use a kite as a discharge, as a place where, because lightning is always looking for a path towards the ground. It's called discharge. All right, the lightning wants to release the charge that it is carrying, and so to understand how lightning is created now would be to understand what this experiment is about. So for some reason the lightning in the clouds was attracted to the key that was lower down or closer to the ground. And there goes Ben Franklin he was credited with the discovery. And in fact, this is actually in the 1740s, so just a couple decades before independence, but certainly wasn't taken seriously until later on. All right, so this is the guy here. Everybody seen this?
Yes, sir.
Yes.
Yeah. So I discovered here in the 1740s, the lightning experiment with kite, key and Leyden jar. So I think they had a jar somewhere there. But the picture didn't show that. But all right, yeah, the key and Leyden jar, it stores static electricity. So he developed what they call a lightning rod. So again, persons were dying from lightning strikes and all of that. So his discovery would help them to say, well, all right, if we could build a rod on a house, then when the lightning strikes, it instead of striking a person that's walking in the rain or whatever the condition is, then having a lightning rod nearby would actually save them life, because the lightning will be directed towards the rod, right? And he was thinking one step further. What if when it strike the rod, we could use the energy from it to do something? And so this is in 1740, guys. This is early times. This was early times. In these days, your greatest grandparents tracing back from Africa could be on the plantations, getting sort of beatings and ill treatment. But he was there discovering electricity as a white man, so it was kind of fortunate like that. Proposed the conservation of charge, saw electricity as flowing fluid, and called the flow direction positive. So yeah, that's where the positive charge come in now. Ben Franklin was the discoverer there, or the person accredited with it. Pretty sure somebody in Africa would have had their own idea about lightning, but then because they're African, yeah, they probably would just throw out the information, or
Sir, I'll be a ritual then, dude, sir.
well, yeah, but but there was also a ritual for this as well. So in Scandinavia. So I mean, people would dance for lightning to come, in the, we're talking about like 700 and 800, that's early times. So people had rituals for lightning as well. But Aside from that, still, that's where static electricity is, right? So basically that's where it began. So the question is now, how does lightning occur? How can lightning be created? Because they actually figure out how to create lightning. You can actually create lightning. In fact, people can actually make rainfall by
Yes, sir. And
yeah.
clouds, sir. And like that, look,
So,
something that's been nice. See.
well, it's
Something
only
was
that
similar
spinning the
to
sea.
hurricane, sir. Like they can't use machine and create. I'm saying he was rain. They can create rain and clouds, sir.
Mm,
It's actually on YouTube, sir.
yeah. So yeah. Let's get into some let's get into some more details as to what happens here. All right. Actually on the syllabus here. Let's just open this to you guys. Anybody seen this?
Yes, sir.
Yes, sir.
All right. So trying to find a simpler diagram. And there is just this whole heap of plus and minus signs in the diagram. I think this is simpler. I like this one better. All right. So just a simple explanation here. What are you seeing in this diagram, first of all?
Protons and neutrons.
We are protons.
Huh?
Where are the protons? Yeah, because
They positively charged something there, sir.
yeah,
they
that is it.
agree.
That is it. We can't call them protons yet. They weren't discovered at the time. They were called positive charges. Remember that the word proton wasn't used until the 1900s. In fact, probably 1913 thereabout. So at this time, we're going to call them positive charges. All right. That's why in electricity, when you learn electricity, the term protons is hardly used. They would use electrons, as electrons were discovered first. But we just call them positive charges, really, at this point. So they are positive charges. You see the plus signs. And which other signs you seeing?
Signs, lightning, sir. And
which other sign you seeing? Positive is one sign. What's the other sign you seeing?
negative charge.
Negative charge. That's the question. All right. So they're seeing positive and negative charges. All right. That is it. No. That is the basis. We're also seeing atmospheric objects. All right. What atmospheric objects are we seeing?
Cloud.
Cloud. Right. So cloud, and of course, we're seeing a surface here below, which would be what we call that, ground, also. All right.
Yes.
So where there's a cloud, there's a ground. You know. All right. So good. So we're seeing cloud, ground. All right, we're seeing plus charge and we're seeing minus charge. All right. Now, let's look at the cloud now. Where are the minus charges located?
Bottom half.
Bottom of the cloud.
All right. So we'll say that it's the base of the cloud. All right. There is a red line connecting the base of the cloud to the ground.
Like positive attract, oh sir, I see it's concept like a positive attract a negative, sir.
All right. So what do you think that red line then connecting the base of the cloud to the ground? What that line would represent?
Lightning, sir.
That's lightning. That is it. So that is the story of lightning. All right. Lightning is basically a connection. It's an electrical connection between the cloud and the ground that we experience. Any questions there?
No, sir.
All right. So we can easily explain how lightning is produced. Again, this is reminiscent of a 2007 question on CXC. They had asked about how lightning is produced. So A simple explanation is that the base of the clouds gather up negative charge. Of course, before this can happen, we hear something. What usually precedes, or what usually happens after lightning is struck? Something happens. It usually happens afterwards. You see a large or bright lightning strike, you always experience something after that.
No, sir. Thunder, sir. Sir,
Sir, I
you
think
Thunder,
they have
yeah,
many types of lightning. They have
thunder,
like chain
thunder.
lightning.
Thunder, January, thunder. One word.
Yes,
Thunder,
yes, sir.
thunder. That's it. Thunder. So notice we say that the lightning form first and the thunder come after, not the other way around.
Yes, sir,
Um,
because light travel faster than sound.
Well, if you want to put it at that, because you'd have done light and sound already. So you understand that light travels much faster than sound.
Because they
However,
probably strike at the same time. One thing is sound kind of a little bit slow.
well,
Like,
yeah. So then, in order for these clouds to get the charge, right, there must be what we call a collision. All right. The story of lightning is two things happening. One, the collision that happens, and when that collision happens, what happens is that the charges get they call them reorganized. Right. So we and then what happens that when the charge them get reorganized now, the base of the clouds gather the negative charge, you just get negatively charged, and then now it is directed towards the ground. So we have terms here, what we use to explain static electricity. Two terms that CXC wants you to use when explaining what happens there. The one of them is this one. This is what causes a collision. This happens because of the collisions. Remember that in the clouds, you have dust and you have air particles there as well, right? So when those rub against each other, with the wind is pushing all of these things through the atmosphere, and certain type of clouds gather. These clouds are dense, so they will have a lot of dust there, and these dust become charged, and so that's process is called friction, when they start to rub against each other up in the clouds, and that rubbing now, as we say, causes the base of the cloud. So maybe just try and draw a cloud, and those of you who do geography will know the different types of clouds. That's so what causes friction. And then of course induction is the other word. Induction is when let's draw the same cloud, or at least something like the same cloud. And what happens is that these negative charges now, which were later called electrons, all right, they just decide that they're going to zap them away on the ground, and a lot of them will just be released there. So and so that's the ground here. So the ground is actually positively charged. So let's put the plus sign there.
yes, sir, and like one chain reaction, sir, right? Because the nucleus then form a certain line, so that's why it causes lining to bend.
The what?
Sir, like,
January, do you remember I said don't over explain yourself? Where is the nucleus there?
no, sir, I was saying that the reason why the lining probably bends, sir, like bend up have so much shape, sir, like it kind of curves or something, sir. May I say because the chain lightning, like the nucleus, sir, no what else.
Yeah, because you can't use nucleus here none at all. We have to go say no.
And I wasn't saying nucleus, sir, if they're negatively charged.
Negatively charged.
Yeah, in a line, they fall in a certain line, sir.
Well, the long and short to that is that there are negative charges in the atmosphere, and negative charges don't like to be near other negative charges, so they will dodge out of the way. So that's what causes a bend in the lightning. So if there are other negative charges around and the negative charges are moving in that direction, then it's going to part ways with it. It's going to repel it. And that's the next principle of static electricity, that the opposite charges attract each other, but the charges that are the same charge, like these negative charges here, they repel each other. And that's why this is why the lightning finds its way to the ground, because too many negative charges are here. They feel like, well, let's discharge, let's repel, and that repulsive force now cause the lightning to strike. And if you are in the way, then you become a conductor, and you might not live to tell the tale after that. Some persons live, I hear, and most don't, unfortunately. Well, that's how it is. So that's it. So these two words with static electricity, friction and induction, that's the story, guys. And so that is, and that's actually in the experiment. That's actually in the lab, and we're gonna go through that shortly. All right. So any questions here, guys?
No, sir.
No, sir.
All right. So again, here's another picture depicting it. I'm a more simplified picture, but this is telling about the lower clouds becoming negatively charged, and then there is sort of an attraction there towards the ground. So that's the story of lightning. All right. All right. So now, let me see though. Those terms we need to explore now. Charging by friction, charging by induction. All right. All right. So now, yep. Going to that that information there. All right. And again, charging by, so basically moving away from lightning, it applies also to other things around us too. So that's the concept there. All right, and this lab now is basically, let me confirm there, a new slide and show you what's happening. All right, so this from Ben Franklin's discovery and other persons. We have Andrea Ampere as well, and Charles Coulomb. Those persons also played a part here. All right, but charged by friction, guys. Now, you see what happens when something is being charged by friction? What is happening in the first picture towards the left?
Sorry to stick money here, sir.
Oh, what is sticking to the ear?
Balloon.
Yeah, what looks to be a balloon, Deshani. Very good. All right. We also seeing charges there as well.
Yes.
Yeah, we're seeing charges there. All right. So in other words, by rubbing objects together, so rubbing objects together, causes friction, causes static friction. So that is important. When you rub materials together, they become electrically charged. So what happens is that you're rearranging the charges, and so when them rearrange now, they tend to organize themselves. So all of the negative charges will be attracted to the positive charges of the other material, and then they will move towards it. So there's a list though, and there's a list of objects that gain positive charge here. This balloon though appears to be positively charged, so the electrons from the here, the negative charge from the here goes towards it. And so when it's rubbed, all right, so there's a transfer of electrons from the here to the balloon. All right, now and this will cause a person's here to become erect and like standing like what's happening here. All right. So that's charging by friction. Now the next in the middle we see a charge by induction, where what happens is an object that obtains a charge now can be used to charge another object without touching it. All right. So induction now is when you become charged now, you start to inspire other objects to become charged. So that's it. Coming like that teacher now, I'm teaching you, and sometimes I have to get in contact with you guys and push really hard for you guys to do the work. When it was face-to-face time, probably someone would get a little pinch or a little nudge there, or a little thump on your arm or so. Any little thing to get you guys to do the work. But then once you start understand the value of work now, you start to see people around you wasting time, and then you say, yo, no do no work, cause no charge up now, cause no really say, all right, start the good night work and feel like say, yeah, everybody else running off it. So the same thing here. The charging by induction is when the object will gain the charge attracts an object that is not charged. And so this is a rod that they're showing here. A rod usually made from plastic though. And you rub it with a piece of cloth and it gets a negative charge, and then it's attracting the positive charges of the metal there. This is called an electroscope. I think I saw this in the syllabus. Not sure if it's on the new one, but certainly an electroscope is something that should be in labs at school. Just a aluminum foil with piece of metal at the top there. I'll show you that some other time. But that's charging by induction. And again, using the example as before, the charging by induction is what causes lightning. All right. The charging by induction is an example. Here, lightning is an example of it. So because the cloud already charged, then it's being attracted to the ground, and then it causes the flow of charge, the other object. Because the ground was okay, the ground was all right. It's the clouds, is the problem. It's the clouds getting the charge now, and then the ground has both positive and negative charge, but because the base of the cloud have negative charge now, the negative charges in the ground are forced away from it, and what that do now is allow the positive charges to come to the top of the ground, and then there goes the attraction. That space between the cloud and the ground is that field. You call it an electric field. So if you are caught in that electric field, being in the wrong place at the wrong time, that's the end of you. People thought that in the old days that it was God and Satan fighting. And so whenever lightning was striking, it was God throwing blows towards the devil on the ground. So for centuries, people believe that. If you were born 500 years ago, you probably would believe the same thing. But we learn now that that's not the case. Thanks to Ben Franklin and the $100 bill that remind us of what he did. That's not the case. So it's actually induction is the word to use here when lightning strikes. Any question here, guys?
No, sir.
No. All right. Because the question is sent on static electricity came in 2007. Very difficult to find that paper though. The past paper booklets from CXC start at 08 now, but when I find it, I'll show it to you. But for now, I want you to have enough knowledge now to say complete this lab here. The terms are defined here. Of course, that's the theory here, and all right, and Antonio has decided to join us. Antonio is quite a casual attendee to the class here. But anyway, so theory. Yeah, so going back then, so you'd have learned this already. We did section E. We were talking about proton, neutron, and electron. All right, let's see if we're going to apply that there. But as I was telling Janari that, protons weren't discovered when electricity was discovered. So we don't call them protons, we just call them positive charge. So protons have positive charge, electrons have negative charge, neutrons have no charge. That's common knowledge here. All right. Atoms have the same number of electrons and protons, and then the atom has no charge. So atom itself don't have any charge, but if you force it by rubbing it, friction, you can cause that charge to be disturbed. And so, however, if you rub things together, the electrons can move from one atom to another. And some atoms get extra electrons, and then they have a negative charge. Other atoms lose electrons, and they end up having a positive charge. Again, if you're losing electrons, then only the positive charges will be left behind. And so that will be the charge of the material after the electrons leave. All right, so friction refers to rubbing two objects together in one way. An object can become charged, they say here, and the friction results in two objects having opposite charges, right? Induction now is a method of charging objects where, well, let me just read what it says word for word here. Refers to a method of charging when particles are rearranged where there's no direct contact. All right, the neutral object only needs to come near the charged object and the electric charge is induced in it. So that word induce means to cause to happen. Almost like bad company really. And so just a little nudge there causing that. All right, so any questions here, guys?
No, sir.
So at the end of today's class, you should be able to say what friction and induction is in relation to static electricity. All right. And there's a series known as the triboelectric series. Tribology is the study of friction or rubbing objects. So there's a series now, which the video, and there are some videos down here that will explain that. You can watch them in your spare time. So this video here, Science of Static Electricity, right here. And it's actually on YouTube. So we'll explain that. And then you have all of these. So this, after watching all of these videos, then you'll know what to do with the lab, with the plan and design. So there's a story here. All right. So what is static electricity? Explain how an object can develop a static charge based on your new knowledge from the videos and observations. Give real life examples of objects being charged by friction and induction. Now, when it talks about real life objects, we could go to this image. We're seeing balloon, we're seeing here, we're seeing a glass rod or whatever the rod is, of course.
And paper too, sir. You can use paper.
Right. So different things cause this to happen. All
Oh,
right.
sir, I think I should rub the pen, or just remember, you should rub the pen in your shirt, sir, or something like that, and then put it on the paper.
Okay. Yes.
We're the one with the aluminum foil, sir, and the plastic comb, sir.
Yeah, you do that.
Yes, sir.
All right, lovely. So so then that's real life examples. So you'll be more familiar with this one. All right. Yeah, combing in here is a one way you can get charged here. So this is something that you can use to write a hypothesis. You could say combing your hair, after combing your hair, you could say that the comb can attract pieces of paper. And so that's by friction there. Let's zoom out. All right. So that's combing in here and sort of before and after situation. So let's bring the before scene and see here. So this could form a hypothesis here. Yeah. So I mean, for this lab, it's easy to carry out. You just need a comb. I think everybody in this class should have a comb, and I'm hoping everybody in this class has hair as well. Maybe some of you might probably January you cut off yours, probably. Benito.
No, sir. My hair is
Alright.
bushy.
All right. Amari, you should have a little hair on your head, but then you're not doing that with us, so you're all right. You're lucky. Dwayne, hair still on your head? So,
Yes.
all right, good. So, you guys should be able to do this, and as we say, strips of paper or something could be used as a test to see if the comb does get a charge. All right. Before combing, though, they said here the hair has a neutral charge, yeah, because it's undisturbed. And then, of course, all right. So Benito, oh, you're logging in back, Benito. All right. So, and then of course, after combing, now there is a charge exchange charge here. The hair becomes positive, the comb becomes negative. All right. We can come to hypothesis here though before you guys leave. Definitely we could say something about the comb and the hair. So you can use the triboelectric series. All right. Show you that in a sec though. Example, rubbing a balloon against human hair will cause the balloon to become charged and attract pieces of paper. All right, this is one example you can use actually. I gave you this one before, so yeah, if you write this one, you get 2 marks for that. And of course, suitable aim to test to investigate.
Sir,
Yes, go ahead.
what's the theory about tape, sir? Like,
What tape?
how does tape deal with this, sir? Like, you notice a tape easy like when I paste on some mistake on it, and if I can
No,
charge us.
that different something that general different thing that when they say tape, I think you was talking the old time cassette tape. But no, adhesive is something different. All right.
Sir,
Okay, sir.
Yeah, yes, go ahead, Benito.
ano ni kami one, what you ever touch it doon na bit, you feel like it's a shock you.
Touch what?
Do na.
Yeah, that definitely happens. Yeah, does happen. Especially if your feet are not grounded. If you don't have on any slippers or you're on a carpet, certainly you would feel a shock there. Or you could. Doesn't have to happen though.
Sir, so that is a example static electricity.
Yeah, that is static electricity. Which yeah, as I talk about that, there are some limitations there. So for example, moisture can prevent static electricity from happening. So humidity in the environment would certainly would inhibit inhibit, sorry, it's will inhibit static electricity. So in terms of, so this electricity, yeah, so that's a limitation there. Precaution, source of error. Certainly precautions, if you're gonna use static, if you're gonna try and demonstrate it, you're gonna make sure that or ensure that surfaces are clean and dry. Ensure clean and dry surfaces are used. All right. And so one source of error, you have Weber source of error for this one. The possibility enough like source of error. Yeah, could be. All right, source error here could be, well, the same moisture, but could be the presence of the presence of moisture, wind. You can't control that, because you might think that, let's say, for example, you hear, let's say that you hear supposed to respond to the balloon, but then it could be just a little bit of breeze blowing, and then you think that it's the static electricity causing it. Saying that that's one. You know, so it's an error here. Your hand as well. So your hand you know, observer not being not being, what you call now, discharged. No, discharge meaning that, for example, when you're handling, if you want to experience static electricity, you are a factor in it. It's like probably there might be something on your hand that's preventing it. And not everybody's hands is the same. So if you're going to use whole objects with your hands, for example, that will also affect object, so observer being charged or discharged will affect it. All right, so yeah, are used. All right, so then that's the source of error there. All right, so then that's pretty much it. Expected results. So you can just follow the outline here, and then you send what you have to me after going through this. All right, so the examples here. So nobody needs to tell me that they don't know what to do. It's here. All right, the videos are there to watch for clarity. And outside of that, if you have any questions, you ask me. Simple as that. All right, so this lab should be ready for Thursday. Any questions, students?
No, sir.
All right. All right, so there you go. So that's it. So that's static electricity for you tonight. So next class on Thursday, we want to go into more serious electrical concepts that will be on the exam. That's one thing I can guarantee, that you will get some electrical questions and that's physics paper. We're going to talk more about that next class, guys. So thanks for coming out tonight. And
Sir,
yes, go ahead, Benito.
this has nothing to do with class, but you have to go take the vaccine because school up Monday.
Oh, okay.
And then say teachers them have to be vaccinated in order to use the
Oh, okay. So I guess that's the end of my career then.
So sir, then they actually said they stop a Moderna vaccine because I harm where cause, sir. Then he put out something, sir. A message.
Oh, so
Johnson I should say, sir.
oh, okay.
AstraZeneca because they say because harm, so they must go stop.
Oh, so them start pointing at the brand name now, AstraZeneca. All right. I think it was one of them that that Michael Sharp got.
Yes,
Um,
sir.
So, well, look at that. Hey,
Sir,
yes, go ahead, Kanye.
sir, I'm more talking about one of my labs, sir.
Mm-hmm. Which
When the class empty out still. Sir, I can't find the link them to.
the link?
Me no know them. Yes, sir, like them just gone out from that group. Sir, the documents them where they send like the love them.
Yeah.
I can't find none of them, sir. Not one.
Oh,
Yeah, because I get kind of old or something.
well,
That happens
well.
sometimes to me, like you know, open.
Well, I believe I'd sent them back this morning though, Kanye. Let me just check that group and see what's happening there. The labs were sent. All right. Well, afterwards, Kanye, you can. You said the links. The links are there.
Sir, uncle link can't think of me, sir, like the class. I just them there alone.
All right, I'll resend them.
Right, sir.
Let me see something. I think I send it. Let me send them. I think I'm gonna resend them right now.
For sure.
All right. So let me see. Yeah, afterwards, I'm sending them. All right, guys. Yeah,
Sir, are we still going to have marathons?
marathons. As in, yeah. You mean like we had for chemistry last night?
Well, yes, sir.
Yeah, we will have marathons and yeah, man, we certainly will have marathons. Why you ask? You want a marathon?
Yes,
You think
sir.
you need one?
Yes, sir.
Yeah, we're going certainly have marathons. We just want to make sure that we just want to get this part of the syllabus out of the way, and then we can talk about marathons. So yeah, we'll have that, Shante. All right. Yeah. So trying to find those things so you can hear and send it soon as possible. And January, I was telling you that the dotted line that you have, they're not touching the graph, they're not touching the line that you draw on your graph. The dotted lines them gone past the line. So let me see.
Sure, because a freehand sketch it.
Yeah, but your hand too free because the hand is so
So I would
free.
have to use the computer line, sir.
Yeah. All right. Let me see something. Yeah, looking at your graph here. All right. Let me just send this over. All right. Yeah, I think this is what you would have sent. And looking at this, yeah, these would have to touch the line. So we have the mark at 50. This mark at 50 here would come right down here. So I don't know what you were thinking. Your line gone all the way out here. It should come right here. So probably might have been a bit happy when you were doing the lab. But this at 25 would be right here and it come right down here. So you'd have lose marks of that. And then of course 12.5, you come all the way to here and you come down. So this is where this will be a T3, this would be a T2, and this would be a T1. So you have that to fix on your own.
Yes, sir. Thank you, sir.
All right. All right. Now, again, let's see. I will try and send this information in the group. I think this lab sheet here. It's quite a bit of stuff here. All right. Just can delete that. All right. So all right. So now let me just confirm this now. Dwayne, how many labs you have?
8, sir.
Okay. So I think it should have 8. All right. So finish that one and then Thursday, we'll take it from there. All right. So yeah, Thursday. All right. All right. So hold on. Let me say this though. Benita, you're the one who introduced the news about needing the vaccine to go back to school. Where heard that?
Sir, me see a post.
A post, okay.
Somebody send me a message from the on Instagram from the government page.
Oh, okay. So all right. So then that's a foregone conclusion then.
So you can't break the system, sir. Trick them up and say get the vaccine. If you have links.
No, there's them record that, man. Yeah. You see, I mean, I don't think they did enough justice though in terms of telling you the full details about the vaccine.
Yes, sir.
Um,
I think it should have taken like 6 to 8 years to test out a vaccine, but this one will take like 1 year or so. Or less.
well, to be fair though, they had been developing for a virus that was close to the corona. As the swine flu was there for about 10 years. So they would have had that disease to and SARS was there to remember. COVID is a variant of the SARS virus. So they had the SARS virus testing. And so when the COVID came now, it would have been a strain of the SARS virus. So they would have had time to test the vaccine. But my issue is the fact that the vaccines are not 100%, you know. There's a lot of uncertainty with how it will work, and so it's actually a weaker form of immunity than natural immunity. But again, them tell the teachers, and the teachers will stay there and just take the
So
information.
I was watching this thing and then it explained vaccines, sir. Why vaccine do a train a body to fight off a certain kind of body. Some kind of some kind of virus or like that train a body. They when they inject a vaccine, sir.
Yeah, it's it's like a memory thing. So immune system memory trigger it. By the way, this was last week,
Sir,
Thursday. Yes.
then how din so bright? I got talk about teacher have to take vaccine. That's not a personal choice.
Yeah. I suppose they can do it, but I don't know. I don't know. They can say it. Ultimately, it's still a choice. So I don't know what's gonna happen there. Maybe there will be JTA brought into play, and then exchange of words, and then what's gonna happen? I guess we end up have to take it, or when a few person decide to take it, them encourage everybody else to take it. So I guess that's it. So maybe I can escape it, but I'll hold out as long as I can. So be it. You know. Let me see something. All right, just trying to get this thing.
The scientists say if you catch COVID-19, it kind of shorten your lifespan by 300 something years, sir.
Okay, it's interesting. It's interesting. So, and that could be possible. It could be. But how long does the how many years the vaccine takes off though? That's the other question. So
That is true, sir. 'Cause I remember getting chicken pox vaccine or something like that, sir, and still catch it.
yeah, different strain. All right, so the date for this lab. All right, so this lab is due Thursday. Everybody see in the lab in the group.
Yes, sir.
Yes, sir.
Yeah. Yeah, lab due on Thursday. The date on the lab is the 29th of the 5th, but it never sent. So I was just gonna send. All right, so 29, not the 5th, sorry, 4th. Change that one. Good thing never copy that. All right, so it was April 29 that I gave this lab. All right, let's save this. All right, and yeah, there we go. All right, so it will be your lab 8. All right, so that's out of the way, guys. All right, guys. So thanks for being here, guys. And we'll be keeping in touch. All right, there's a group, and there's all different kind of media that we can communicate on. So until Thursday, Until then, I'll see you. All right. What's happening here?